Following on from my previous video about creating a Lambda function for a depreciation schedule, this video will show you how to create a function that calls that function several times for each asset in a table. As a reminder, the schedule function works like this. We select the cost, the salvage amount, the number of periods, and the start. We provide a calculation function, a period function, and we won't return the header this time. So this is the schedule for the machinery asset. So we will do this for each row in the table. To differentiate them from each other, however, we will need another column off to the left which contains the asset name, and that will use this function or a variation of this function. So we'll use the expand function, and it will be the same height as the schedule, one column, and it will be padded, i.e. filled with the asset name. So that function produces a column which contains the asset name. Rather than write the code from scratch, I'm going to talk through the code that's already written. So schedule stack is the function that will work on this table. It accepts three parameters: the asset purchases table, which is the table that you've seen in columns B through F, depn function, so a depreciation function, those were defined in a previous video, and a period function, which is defined in a previous video as well. So the first thing that happens is we give this asset purchases table a shorter name so that we don't have this long name everywhere. That's just a matter of convenience. We'll call that T. The next thing, because period function is an optional parameter, we need to handle what happens if it is not provided by the user. So we say if period function is omitted, then let's use the depn.byYear function as the default. Otherwise, we'll use whatever is provided into that function, and we'll assign the result of this if expression to the name period fn. Next, we define a row index, which is a sequence which is as long as there are rows in the asset table. That will be used later. Next, we define a function, a Lambda function called getVal. Now what getVal does is it accepts a single parameter, which is a number, which is intended to represent a row in the asset table. So if we pass 1 into this getVal function, it will create this lambda, this inner lambda, which is itself a parameter of a function of one parameter, which calls the index function on the table for that row, for that column. So it's not a complicated function, but it just allows us to repeat this index call over and over again in a slightly simpler way. So we'll see how that works in a minute. The next statement is defining this schedule function, and this schedule is a lambda function of one parameter. This parameter is B, and it represents the row in the asset table. So B is a row number in the asset table. And the way this function works is it first creates this name called args, which stands for arguments, and args is passing B, the row number, into the getVal function. So it is creating this as a result. So that is the result of this args getVal B. And what we end up with is a lambda function that accepts a column number to retrieve a piece of data from a row. So by assigning getVal B like this, this is actually represents a row of data from the asset table. And we do that because we can now call the depn.schedule function, which was explained in great detail in another video, so I'm not going to go into it now. And using that args, which again is a row, we can just return column 2 into the cost, column 3 into the salvage, column 4 into the life, column 5 into the start date, we pass in the depreciation function, we return true vertical array, we pass in the period function, and we don't return the header. So this schedule is a lambda function. It takes a row number and returns the depreciation schedule for that row in the asset table. Continuing down the script, the next statement, we return the schedule for the first row in the asset table. So in the example on the screen, this statement will return the schedule for the machinery asset. Remember before we mentioned that we need to add a column for the asset name. This asset name call statement is a lambda function that accepts the name and the schedule to which the name applies. And it uses the expand function that we looked at a moment ago to create a column that is as tall as the schedule that contains the asset name. On the next statement, we are using the asset name call function, passing the value from row 1 and column 1 into the getVal function. So that returns the machinery name. We're passing the schedule for the machinery asset, and we're returning the single column containing the name into this name call 1 variable. Next, we are preparing an initial value to pass into the reduce function. So the initial value is nothing more than the name call, which is the word machinery all the way down, and the schedule for machinery. So we're horizontally stacking those together. The next is the last part of work in this function, and this is the name schedules, and we're using the reduce function to iterate through the row index. So first of all, the first parameter of reduce is the initial value, and that is defined here. So that's the H stack on name call 1 and schedule 1. The second parameter is what array do you want to scan through. So we drop the first row from the row index because we've already defined the schedule here, and we want to scan through the remaining row indices. So in the case of the example on the page, we will be scanning through numbers 2 and 3. But of course, if the table were much longer, we would scan through all of the row indices one by one. So we're scanning through 2 and 3, and we are applying this lambda function to each row based on its position in the table. So the lambda function in reduce accepts two parameters, one A, which refers to the accumulator, and B, which refers to the current row. We're using let to define schedule B as the schedule for the current row being iterated over. So B is the number. So in the first instance, it will be 2 and then 3, and it's creating the depreciation schedule for that row. Similarly, we are creating the asset name column for row B in the same way that we did for row 1. And we're passing into it the value, which is the name from column 1 of row B, and the schedule for row B. And that will create the name column for row B. And finally, we are stacking the accumulated value, vertically stacking the accumulated value, i.e. each result from each row of this reduce operation, with the horizontally stacked name column and schedule from the current row. So the result is we start with the initial value, which is defined above. We then stack on top of that the H stack of row 2, and we stack on top of that the H stack of row 3. And if we were to add more rows, it would continue in that way, creating a stack of schedules. And finally, we return the stack to the spreadsheet. As a quick demonstration of how schedule stack works, let's just do it right here. This is schedule stack. We pass in the table, the depreciation function we want to use, the period function we want to use, which is by month in this case, and that is it. You can see we've got a schedule for machinery, a schedule for software, and a schedule for the robotic T server. And that's the end of that. Thanks for watching.